All right, this time we are solving a little bit harder equations using combining like terms, but our like terms on this time are on both sides of the equal sign. So as you might notice on number 1, we have a like term here that connects with a like term there. Okay, they're on different sides of the equation. These right here are also like terms. They are also on different sides of the equation. Remember, like terms are the ones that look alike. These are constant numbers. They look alike, they're actually like terms. These have the variable of y. They're also like terms, okay? I'm gonna go down to my number 3 real quick, just to kind of give you an idea of what this stuff is supposed to look like. First of all, the only like terms I have are 4 and 6, okay? I cannot combine them nice and easy and just make 10. It doesn't work that way. This divider right here, this line is separating the sides of the equation, and it's making it difficult for us to just combine them like that. That is when the whole inverse operations, or whatever you do to one side, you do to the other thing, comes in, okay? So this is how I move like terms from one side to the next, so that I could start working and solving equations. I'm going to move this 4x and bring it over here with the 6. I'm gonna put the answer over here on this side. The reason I didn't take the 6 and move it over here to join this side is because then I would have nothing left on this side of the equation. It'd just be a bunch of stuff over here equals blank. Okay, I'm not gonna do that. I need to move this one over here. Kind of have to keep things in a balance. So the way I'm gonna do it is I'm gonna subtract 4x, okay? If we technically had 4x's, 1, 2, 3, 4, and we took away 4, we have no x's left. Same thing, okay? It's 0. But whatever I do to one side, I have to do to the other. So now I have 24, because I'm just gonna drop that down, equals 6x minus 4x's is 2x's. Same thing. If you wanted to draw it out, you could. Or you could just realize that 6 minus 4 is 2. And you have to keep that x, okay? So the last thing I need to do, and this is a one-step equation at this point, is divide by 2 on both sides. I now have x equals 12. 24 divided by 2 is 12. Okay, that's kind of like the preview of how we wanted to do it. I did number 3 first because it was easier, and it's gonna give you a better idea of what we're gonna have to do up here. Okay, so now I'm gonna move some stuff around. I decided that I want to do, let's just take the 3 and move it over here. Honestly, we could start anywhere. We could take the 4 and move it over here. Actually, yeah, let's do that. Let's take the 4, move it over here, and I have a reason why I wanna do this, and I'll tell you the reason. This is a negative 4y. If I want to move it, make it go away from this side and put it on this side, I'm gonna have to do the opposite. I'm gonna have to make it go down to 0. So I know that if I add 4 to a negative 4, it makes 0, right? So good, that's what I want to do. Whatever I do to one side, I have to do to the other. The reason I chose the negative 4y to move first is because I'm working now with positive numbers. I'm kind of eliminating my negatives. It's not that it's a bad thing. It's not that you have to do it this way. It just is a little bit easier to work with. 3y plus 4y is 7y, and then I have that minus 8 equals 13. I'm left with a two-step equation, and you might notice that I said that this and this are like terms. And they are. And we were using like terms even whenever we were doing two-step equations, and you didn't even know it. If I wanted to move this 8 to this side, I would need to add it to negative 8 to make it go away over there, okay? Now I have 7y equals, and 13 plus 8 is what, 21? Divided by 7, y equals 3. Did it. Okay, go ahead and copy down number 2. This is what we're gonna do. I noticed the same kind of thing is happening. I have a negative 4 and a positive 8. If I were to subtract negative 8x, or subtract 8x on this side, I would say minus 8x. I would subtract 8x from here, so it would be negative 4 minus 8. It gets a little tricky that way. We can do it though, because I want to show you. So I'm gonna subtract 8 from both sides, okay? 8 minus 8 goes away, obviously. I now have negative 1 equals 47 and negative 4 minus 8. Now here's the deal. This does not say negative 4 minus negative 8. It does not say that. It says negative 4 minus 8. That's all it says. So please, when you type this in the calculator, don't put two negative things right here next to each other because it changes the whole problem. This is negative 4 minus 8. You will get negative 12 when you do that, okay? If you did negative 4 minus negative 8, you would get 4. 4 would be your answer. That's not the answer, okay? Be aware. All right, so let's keep going. Let's take this 47, move it over here with the 1. So I'm going to subtract 47 from both sides. When I do it, it goes away here. Negative 1 minus 47. Again, same thing. Don't do minus negative. I didn't write minus negative. I just wrote minus. Negative 1 minus 47 is negative 48 equals negative 12x. When I am ready to take this negative 12 and divide it on both sides, I divide the negative with it. Don't leave the negative alone. I don't just say divided by 12. I have to do divided by negative 12. Negative 48 divided by negative 12, if you type it in the calculator with both of those negatives, because that's how I see it, that's how I wrote it, that's what it's meant to be, that equals a positive 4. And then those 12s go away, and I have an x. All right, everybody got that down? Gonna move on to number 4. These get a little bit trickier, okay? We're gonna do a little bit trickier and then we'll be done. I have one more question after this and then you're good to go. Okay, so let's start working with the like terms. It looks like I have that one as a like term. That one, I am gonna include the negative when I'm drawing my circle because that is, or the minus sign, I guess. That means the 3 is negative. That's what that means, okay? And the 6. So first of all, it looks like I have some like terms that are on the same side as each other. Remember, this is number 4. It's not like a actual part of the equation. I have like terms on the same side, and I have a like term on the opposite side. We start with the ones on the same side. Put those together first, just like we had a number 1 video where we were learning just the like terms on the first side. That's what we're supposed to do. So 4x minus 3x just gives us 1x. Now a lot of people would want to write 1x like that. And you're not wrong. But the way we write 1x in algebra is actually literally just an x. 1x. That represents 1x. It is like people like to call it an invisible one, but technically it's literally showing you an x, just 1x on the paper. All right? And then I'm going to write this minus 2 because we did nothing with it. And I'm just going to keep writing the rest of the equation. Haven't done anything with those yet. I'm going to recircle my like terms because I still have like terms that I got to put together. Let's take this x and subtract it from both sides. You could have taken the 6x and subtracted it from both sides, but I didn't do that. X minus x goes away. 6x minus x, because remember, it's a 1x. Is technically 5x. So we have negative 2, 5x plus 10. Okay, now let's subtract the 10 from both sides. This is negative 2 minus 10. It gives us negative 12 equals 5x. Divide by 5 on both sides, and 12 over 5, negative 12 over 5 cannot reduce. So that is my answer. Oh, I'm sorry. I didn't know. I wasn't looking at the screen. Didn't know y'all couldn't see. My bad. Okay. Number 5. Last question. So same thing here. We have a like term here. We have a like term here and here. I'm just going to go ahead and do those colors with my other color pen so we don't get confused because there's so much purple or pink or, purple. Okay. So let's put these like terms together. We have negative 5x and negative x. Negative 5x, negative 1x together makes negative 6x's. And then we have minus 2, we have 4x plus 1. All right, let's take this away. Like I said, well, not like I said. Those two are also like terms. Now they're on opposite sides of the equal sign. That's a little bit trickier. We have to actually move stuff around using inverse operations, not just combining it nice and pretty like it is when it's on the same side, okay? So I'm gonna subtract 4x from both sides. Negative 6x minus 4x is negative 10x. Remember, it's not minus negative. Minus negative is a whole new deal. That goes away, so now I have 1. I'm going to say plus 2 on both sides, so that goes away. And then I have negative 10x equals 3. Now remember, these don't have to be nice and pretty. Negative 10x, dividing it on both sides so it goes away from the x. You have x equals, and then the fraction, oh, that is a 3. Negative 3 over 10. The negative can go in front of the fraction, or it can be tied to the top number, kind of like that one was. It's either way, it's still a negative fraction. That is how we work on combining like terms with equations. We will get into even harder equations next week, but the more you practice, the better you get out of it. Please, please, please use paper, write equations down. Don't use like little equation solver apps or stuff like that, because that just takes away from it, the whole thing. And you need to know how to solve equations before we move on in algebra. It's the first unit for a reason. You have to know it, okay? You have IXL assignments to do, so make sure that you are using your notes on those IXL assignments. Okay, good luck, and let me know if you have any questions.